Hello everyone, myself Snehal Shinde, lecturer in Praveen Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Elements of Electronics. Subject code is 22213. Unit 1 Semiconductor Diode. We have started the PN junction diode. Now in this lecture we will study forward biasing of the PN junction diode. We have studied P-type semiconductor is fused to an N-type semiconductor, creating a potential barrier voltage across the diode junction. So this is the PN junction diode in a forward bias region. It is having a very small depletion layer, and here is the circuit diagram. It consists of the resistor, PN junction diode and the potential DC supply. Below is the semiconductor diode symbol, and in forward bias region it will act as a closed switch. That means the current will flow through it. Next is the reverse bias of the PN junction diode. You can see in the figure, if the P region of a diode is connected to the negative terminal of the external DC supply and N region is connected to the positive terminal of the DC supply, then a diode is said to be the reverse bias. The reverse current is denoted by I, and it flows from cathode to anode of the diode. Thus, reverse current flows exactly in the opposite direction that of the forward current. Resistor R is connected to limit the reverse current. So the operation of the reverse bias diode, when a diode is reverse bias, holes in the P region are attracted towards the negative terminal of the supply, and electrons in the N side are attracted towards the positive terminal of the supply as shown in the figure. Widening of the depletion region occurs due to the movement of electrons and holes away from the junction. Width of the depletion region increases as shown in the figure. This happens due to the creation of more number of positive and negative immobile ions. Increase in barrier potential due to the more number of ions present on the opposite sides of the junction. The barrier potential or junction potential will increase. The process of widening of depletion region does not continue for a long time because there is a steady flow of holes from right to left, that is from N side to P side. Current flow in the reverse bias diode is the P region consists of a small number of electrons and the N region contains a small number of holes. These are called as a minority carriers, which are generated thermally. The minority electrons in the P region are attracted by the positive end of the DC supply. Hence, these electrons will cross the junction and constitute the reverse current IS of the diode. The reverse current is also called as a reverse saturation current, as this current is due to the minority carriers. It is small in magnitude, typically a few microampere for germanium diode and for few nanoampere for the silicon diode. The reverse saturation current depends on the temperature. It doubles its value for every 10 degrees Celsius rise in temperature. Hence, at a constant temperature, the reverse saturation current remains constant independent of the reverse voltage. So this is the reverse bias working of the PN junction diode. Now next is the VI characteristics of the PN junction diode. So as the PN junction diode work in the forward bias and reverse bias region, so the forward characteristics are shown in the figure, that is forward bias, as you can see in the graph. The graph is plotted between the anode to cathode forward voltage VF versus the forward current through the diode IF, and the reverse characteristics are plotted between the reverse voltage VR versus the reverse current IS. So this is the characteristics. In forward bias region, if the external voltage is applied on the silicon diode is less than 0.7 volts, the silicon diode allows only a small negligible electric current. When the external voltage applied on the silicon diode reaches 0.7 volts, the PN junction diode starts allowing large electric current through it. At this point, a small increase in voltage increases the electric current rapidly. The forward voltage at which the silicon diode starts allowing the large electric current is called as cut-in voltage. The cut-in voltage for silicon diode is approximately 0.7 volts. So the voltage at which the forward diode current starts increasing rapidly is known as a cut-in voltage of a diode. The cut-in voltage is very close to the barrier potential. So cut-in voltage is also known as a knee voltage. Now VI characteristics working in the reverse bias region. Due to the thermal energy in crystal minority carriers are produced, these minority carriers are the electrons and holes pushed towards PN junction by the negative terminal and positive terminal respectively. Due to the movement of minority carriers, a very little current flows, which is nanoampere range for silicon. This current is called as a reverse saturation current. When the reverse voltage is increased beyond the limit and the reverse current increases drastically is called as a reverse breakdown voltage. Diode breakdown occurs by two mechanisms, avalanche breakdown and Zener breakdown. So the current flowing through a diode in the reverse bias state is the reverse saturation current, which flows due to minority carriers. Therefore, it is treated as negative current. As the reverse voltage is increased, the reverse saturation current remains constant equal to I0. If the temperature is constant, this is because reverse saturation current does not depend on reverse voltage, but it depends only on temperature. But as the reverse voltage reaches the breakdown voltage value, a large current flows through the diode. So, we define the reverse breakdown voltage of a PN junction diode as a reverse voltage at which breakdown takes place and a large reverse current starts flowing through the diode. So this is the VI characteristics of the PN junction diode. In this is the PN junction diode. Here it is the symbol. Arrowhead is the anode terminal and this is the cathode terminal. So conventional current flow will be from anode to cathode. This is the forward characteristics. This is the reverse characteristics. Forward characteristic, it is plotted between the forward current and the forward voltage. So from here, as we increase the voltage till knee point, the minimum amount of the current will flow. As soon as it reaches the knee voltage, suddenly the current will start rapidly increasing. So this is the characteristics of the forward bias diode. Now in the reverse voltage, here in the x-axis reverse voltage is there. On the y-axis reverse current is there. So at start the reverse current is of the minimum amount, that is called as a saturation current, till the reverse breakdown voltage. As soon as the breakdown voltage takes place, then suddenly the current through the PN junction diode, it increases and this region is called as a Zener breakdown region or the avalanche region. So in this lecture we have studied the reverse bias diode, PN junction diode. We have explained what is the PN junction diode in the reverse bias region. It will act as a, in the reverse bias region, it will act as a closed open switch, and in the PN junction forward bias, it will act as a closed switch. Closed switch means current will flow. Open switch means current will not flow. And then we have discussed the working through the VI, voltage and current characteristics of the PN junction diode in forward and reverse region. How the current will flow, when the current will flow. So this was the characteristics of the PN junction diode. Thank you.